actually kneels down there in the front, enables easier offload of the booster, which they align those tracks and slowly winch it and pull it out of the front of the Antonov aircraft, where it's loaded onto this transportation dolly. And the goal of this phase is to get the booster from the airstrip over into the building we call the ASOC. It's actually the building we're in right now today, George. It's the Atlas Spaceflight Operations Center. So they bring this down. This occurred probably about late May. Was transported down to the Cape Canaveral Air Force Station. The first flight of the Antonov brought that down here, where now that these guys are moving this over into the ASOC, the Antonov is now turning around, heading back to Decatur to pick up the Centaur, which a couple of days later has landed, and now they're offloading the Centaur, the upper stage of the Atlas V rocket, and doing a similar type transportation operation to move it from the Antonov and deliver it over to the ASOC, where it's stored for a little while to do a kind of a receiving and inspection, but nothing more than that. It's waiting for its chance to get moved out and integrated in the vertical integration facility for stacking operations. So you can see those are very tight corners. They have handlers going around the vehicle watching at all times, moving it real slow to make sure that they don't hit anything. And there's our booster is set there on the side. And the Centaur is being backed into position right next to it. Okay, so now in mid-June, they're ready to start the stacking operation out in the vertical integration facility, and here they begin the transportation operation to take the booster out to Complex 41 in the vertical integration facility. And this is another long day of work where they've got a lot of lift operations. They take the transport vehicle out there, get it aligned, and you can see they use both a mobile crane there and the facility crane that extends out and helps lift one end. So they've got a handling fixture on the back end. They then lift it up, get the transport vehicle out of the way, where I think a later shot will show this actually setting down on what's called a breakover fixture, which is positioned on the rails outside of the vertical integration facility and allows that booster to be swung in and slowly lifted. There you can kind of see the breakout fixture on the bottom there, and that's on those rails, and those rails slowly push toward the vertical integration facility and allow that booster to be rotated into the vertical position. So it's lifted up, brought inside the facility, and lowered over the launch head of the mobile launch platform. You can see some of the taglines. So obviously we had good weather on this day, and weather operations and all these operations usually begin with a weather briefing and some sort of pre-crew briefing to make sure that all the weather is a go for the day. And now we've transitioned. Now we're showing the arrival of one of the solid rocket motors that will be utilized on Juno. And as you're aware, Juno is we call an Atlas 551 configuration. It actually has 5 of these solid rocket motors on board. This video will show you the offload and the loading operation of one of those motors. Again, these are solid rocket motors built by Aerojet, brought to the Cape, offloaded on the transportation trailer onto this erection trailer where it's rotated to the vertical position. The facility crane can then lift this solid rocket motor up and bring it inside the facility. You can see workers watching closely. None of these operations happen quickly. Very good shot there of the erection trailer being raised, and here's the motor being lifted and taken inside the facility.
And you said there's 5 of these on this rocket, is that right?
Juno requires all 5 of these solid rocket motors, which is the most that the Atlas can handle. You'll see MSL coming up as a 541 configuration, so they only require 4 solid rocket motors. But
will these all ignite at the same time on the ground, or
these will all ignite at the same time on the ground? And I think Vern will tell you a little bit about the flight operations he's coming up, but they'll jettison just a second apart from each other. But here it is again, taglines, operators watching, and you can see that all 3 or all 5 of the motors at this point have been installed. So that operation, it takes about 1 day to do a solid rocket motor. So the more motors you have, obviously that added about a week to the schedule with a 551 configuration. And now we've brought the Centaur upper stage out to the vertical facility to rotate it and lift it and mate that to the top of the stack. what wasn't shown there is in between the solid rocket motors and the Centaur, there was what they call a booster interstage and a Centaur interstage, which were also brought out, taken up, and installed on the vehicle. So the Centaur can set down on those. And here, at the end of the video, we see the operations. I think Jan told you a lot about what went on out at Astrotech and the encapsulation process. And here, on about a week and a half ago, we rolled out the encapsulated Juno spacecraft, and it's being taken out to Complex 41 and lifted, and this will complete our stack of the entire Juno launch vehicle. And this occurred Wednesday of last week, so not that long ago. You can see they do some final checkouts, a final integrated systems test after this to make sure everything is checked out and working. And that brings us to where we are today.
Well, the interface between the spacecraft and the rocket, is that pretty much standard for every mission, or is there something that's customized between the spacecraft and the rocket? Is it different, or is it?
Everyone is different. ULA does have a catalog of pretty standard interface and payload separation systems that they use, but those can all be different and modified. In the case of Juno, we had an actual extra adapter space, adapter put into the stack to allow clearances of the solar array. Solar arrays inside the fairing. So actually my involvement with Juno goes back to really the concept phase. I was involved. I'm proud to say I was involved from when it was a concept. It was highly competed back in NASA's announcement of opportunity process. So I've been involved from Juno from the start in evaluating, their launch vehicle needs and hopefully getting them, helping them get to where they are today.
So seeing that spacecraft separation from the Atlas will be a high point for you
That's
today.
What we're all waiting for. We're looking for a good separation, making sure we put them on the right trajectory, and watching those or learning that those solar arrays have deployed successfully.
Well, John, thank you very much, and we'll be looking forward to that as well. Thanks for